Morning, YouTubers. On today's episode, I got something a little bit different for you guys. I have an actual job that we're going to do together. So what I got here is a fan shroud, or what will be a fan shroud, for some sort of old Model T or something, I guess. I haven't seen the vehicle, I was just given this to weld. So my understanding is they're going to cut this top plate out to fit the fan, and then this goes up against the radiator on the thing. And my job is going to be to weld this whole top all the way around, as well as weld up these corners, drill the rivets out, remove the rivets, and then weld in the hole that the rivets are in, and it's also riveted back over here. The clamps that you see on the other side, those are just to hold everything together square over there. Once I weld those corners, the clamps come off. So that's what we got cooking. Let's get into it. The first thing that you're going to want to concern yourself with is how clean this material is. Now, if you look over here, I've already buffed some of this, but since this came to me sort of already assembled and riveted together to hold it together, because this was all test fitted, I can't really access that area inside of there to clean it better. So that's one of the things I guess it bothers me anytime I have to weld something that's halfway bolted together that needs welding with aluminum, is that since I can't access in there to clean it, the welds aren't going to be the best. However, in the case of this, because once I weld this, the rivets come out, this clamp inside that's holding this together gets removed, and I'm going to weld the inside, and then this is going to get ground down. I guess it really doesn't matter. And let's be honest, this doesn't go on a rocket ship for NASA to go in outer space. It'll be fine anyways. It's just I'm kind of a stickler and like to do quality welds. This is one of those cases where we may have a little bit of an issue with that. Not the end of the world. I also have these tabs, which are conveniently labeled, like number 4 here, that have to get welded on the outside perimeter because this thing gets bolted to a radiator. So we got to be pretty particular on where we mount those. Luckily, the person marked everything up pretty good, so we should be able to follow it and not make a mistake. So if you look here, my prep consisted of a scrubby, brand new green Brillo pad. I got one over here, I'll show you. One of these. And I scrubbed everything down inside as well, because if you just clean this and this top plate and leave that, well, you're going to pull contaminants off of that. And then I scrubbed all the edges down all the way around on this. Now, I have not acetone wiped it yet. That's going to be the next step right before I actually weld this. So let me get this top plate out of the way, because we're not going to need to use that for a little bit. Another thing too, while we're here, I'm going to mention, I don't know who bent this, okay, but what I found is a lot of aluminum flat bar like this, once you bend it like this, it has no structural strength. Now, I don't see any cracks in here, but I would be a little leery of bending this. There's certain types of aluminum that just don't take well to big 90-degree bends like this. But that's beyond any of my concern. I'm not welding on it here. I just wanted to let you guys know, be very careful when you're bending, especially thicker flat bar like this. You can run into cracking issues. So let me reverse this. What I'm going to do is just clean this up a little bit better, and then I'm going to run a weld or a tack up here, tack down here, and same thing on the other end over here, so that I can get these clamps out of the way and prep all this better. So that's what I'm going to do now. I have everything positioned here. This clamp is luckily kind of holding everything flat. I have this corner slightly off my welding table because if you try and slide it back here and try and start the TIG arc down here, you're going to end up having the arc wandering to this big thick steel chunk that's my table. So by having it slightly offset, it'll keep the arc on the aluminum. My settings right now are AC balance 75%. I have my machine set for 180 amps. I'm not going to use all of that, but that's what I have my setting at. Frequency is 100 hertz. And all I'm going to do is tack weld here and trying, I guess, a little bit lower here. I don't want to smoke the powder coating or the clamp there. So I'm going to have to be pretty careful about that. I'm just putting 2 tacks here, and then I'm going to spin this. And I'm going to run a weld across. Now I got this empty ammo container. It is empty. I'm not going to weld on here full of ammo. And I'm going to run a weld here. The reason I do this is that I can get a really nice weld because I'm propped up here. If I were to do it off the table, it would be a little bit harder to be consistent. All right, so this end down here, I welded the inside as well as the outside. Like I had said, that's going to get ground off and smoothed out a little bit, so it'll look good no matter what. The main goal I was looking for here is I wanted to get a decent enough weld to where when it's ground down that there's still weld left. The strength is going to come from the inside where I'm welding it. The outside is more or less just filler for the sake of having something to grind down and give a clean appearance. Now the corner, I stopped a little bit before the corner. I'm going to do that so that when I lay that top sheet on it, I'm going to have to do some fitting, and I'll be able to tack the corner and fill this into the corner of that top plate, and it'll all blend in really good. If I would have left this proud, I would have had to have come back and sanded all of this just to get it to where it was ready to weld. So I think I did pretty good there. Definitely not my best welds. Now what I'm going to do is I'm going to drill out these rivets or cut the inside. These are just aluminum rivets, so it shouldn't be too hard. But I'm going to cut out both sides and remove the bracket holding this corner together. And then we're going to fill the holes here with TIG. I got the rivets popped out of there. That was kind of a pain. They had swelled a little bit more than I thought and where they passed through here. So I ground the insides off and then hammered them through basically. Because my shop's kind of in disarray, I didn't have easy access to drill bits to just drill them out, but it worked all right. So I buffed the area around where I'm going to be filling in this hole. I don't have to worry about full penetration here. This is just to cover it. You're not going to see the inside of this anyway, so I'm just going to fill this hole right here. So now that the exterior is all fully welded and prepped, I'm going to weld these tabs. So these things are what bolts go through in order to attach this shroud to the radiator assembly. Now, he was kind enough to really label this great for me. So mounting tab 1, this is 1. I thought it was 2 at first, but it's definitely 1. And then even has little lines there. So all I'm going to do is line this up and then run a bead. Now, being that these are tabs, I want to make sure that I get a weld around both corners. Always wrap your corners. Remember that. And then when I'm going to flip it over, once I'm done with all 4, and I'm going to weld the face of it. And then I'm going to grind that down. Because I guess this has to fit tight just like it is on this bar here. So if there's a weld that protrudes, that's going to be an issue. So I'll have to weld it hot and then just grind it down in order to make sure that there isn't an unfused part there. Because if this thing gets to rattling by not wrapping the corners and having penetration there and then not at least having something on the other side of it. Over time, this tab vibrating like this, it's likely to just crack right like this, right where the weld is. So I want to be sure that I have that set up to where it lasts a good long time. So our tabs are all on. I didn't grind the face of the welds that are down on the table here yet, but they'll be all right. I got this plate on here that the fan mounts to. Whoever cut this plate up to fit, they did a really good job. I mean, this thing is exactly the size on this side, and this. It's a little bit long here, but that's all right. I'm gonna fully weld the sides here in this, and then I'm gonna grind the face down to fit a little bit better. But overall, I mean, by having this fit up like this saved a lot of time. So that's great for me, because I don't like, you know, sitting here sanding to make stuff fit any longer than I have to. So that's an awesome job they did. So I'm going to start out by tacking the corner here, probably put a tack in the middle and a tack on the end. Same thing, I'm going to put a tack up in the corner, tack in the middle corner. At that point, I'm going to fully weld this back seam, then probably this side, that side. There's a lot of ways you can go about this. Since this is pretty thick aluminum, I'm not too afraid of it warping. Not to mention, I mean, almost all of this is going to be cut out for a hole for the fan. So it's going to kind of warp anyways when it's done being welded and then cut. It's going to move a little bit. Not that it's going to be flimsy, but I think you understand what I'm saying. Like all of that being removed, there's going to be movement in it. So I'm not too concerned. And aluminum really doesn't pull that bad. Like you saw me weld these tabs on, and it's not like they bent way up after I welded them. If this was stainless steel or thin sheet metal like auto body, yeah, you definitely would want to watch your heat input. But for this, I don't expect it to bend or warp too much, so I think we're in good shape. Now, from a running a weld perspective, I may be able to run a continuous weld all the way down here. We'll have to see if I can get my hand position just right to do that. I got a couple tricks up my sleeve for that. But worst case is we'll just run a weld to the middle, stop, reposition, restart to the end. That way we get a pretty decent looking weld. Now that weld, I'm unsure if it's going to be ground off. I have no idea, but I'm giving this to the customer pretty much with welds intact, and they can choose to do what they want. All right, guys, pretty much finished this up. Thanks for coming along for the ride here. Not my best work, not my worst work, but we got the 4 mounting tabs welded on, welded all the way around, including the small little edges. That way when these things vibrate, that this isn't likely to break off on us, or on the customer anyways. Started here. Overall, it welded pretty decent. The top part here really welded pretty poorly, and I'll take the blame on that one. My prep work really wasn't that good. I used a grinder and polished the overhanging edge off and just left it a little too rough. And long story short, prep work matters. Like when you prep work really good, you get decently clean welds like this. Well, the top is not in the best shape, but I'll own up to my faults and we can all learn from them. So the bottom here, overall welded pretty good, not the best, not the worst. Ran the bead all the way down there. And then this top probably looks worse than it really is in person. Doesn't look that bad, but because this thing just wasn't beveled that good, I didn't clean it good enough. That weld pool, rather than it being just nice and consistent, it was just kind of bubbling around and just trying to get the amperage, everything dialed in. It was very difficult, and you can see the bead kind of sagged and hit more of the bottom plate. Just, again, aluminum, I'm telling you guys, prep work is everything. I even left in the video, because I thought we could all learn from it. When I welded from this inner corner over, the weld pool just exploded on me, and it just literally looked like pond scum, just like a volcano boiling in this corner. Just could not get it to weld clean. So I ended up grinding this down and then just running a real hot pass over it just to get fused. Now, I believe that the welds are going to get ground down on this quite a bit, if not the whole thing, I'm not sure. But this is apparently in an area you're not even going to see it. So visually, not the end of the world. If this was like for a normal customer, I mean, I'm doing it for a buddy of mine's father. I would have redone a little bit, like this top, just cleaned it up a little bit so it's, you know, A-okay, a little bit better. But for where it's going and what it's doing, I don't think it's that bad. Overall, the welds have almost full penetration onto the inside, and I even welded the inner corners just so that if a crack ever were to start, it's highly unlikely, just because it's tacked inside in the corners and in the middle. So yeah, there you have it. Thanks for coming along. Hopefully you learned something from my mistakes, and obviously next time I do one of these, I'm going to be doing a lot more prep work to make it cleaner and a little bit easier on myself so that it welds better, especially on that top. The rest of it wasn't bad, but that top, totally my fault. That top weld kind of bugged me, so I ran another pass and it cleaned up a lot. Sometimes the little details matter even though it's not going to be seen. Well, until next time, take care.